Welcome everybody to week one and talk one of Programming Fundamentals. I hope you're all online and you can listen. So what I'm going to ask you to do is going to ask you just to give me a thumbs up if you can hear me and everything is okay and you're there. No. Oh, we're too early. Brilliant. So what I'll do is I'll give you a few minutes. I'm going to start at 1:15 to give everybody a chance to log in. And now that I know you can hear me, we'll be good to go. Okay, I'll put back on the timer. So when the timer goes, you'll know we're starting. Yeah, we're good to go, I think. I hope we'll figure it out as we go along. So, welcome to our first week. There was a few beyond there at 10 past when I realised I didn't know the difference between 10 past 12 and quarter past 12. And I started 5 minutes early. But anyway, we're going to start for real now. So, as you'll see, Mairead has sent out a Slack message to say that I'll be doing the live today and she'll be on Slack. And that's the way we work. So, for the next 12 weeks, one of us will be giving the live lecture and the other one of us will be on the Slack. So that's where you can ask any questions. So if you can't hear me, if I'm too loud, if I'm too quiet, um, technical issues like that, just let us know. If I say something you don't understand, again, just let us know and Mairead will go through it. I'll be taking breaks throughout the lecture. I talk a lot, so hopefully I'll give you enough breaks. And what we'll do is during those, if I'll go through the questions and I can, address them, some of your questions if I need to during the lecture. If not, Mairead just answers on Slack. So if we're good to go, I'm just going to check Slack again just to make sure that everybody is okay. So can I get the thumbs up again, just to let me know that we're good to go? And then I'll get going. There's probably a little bit of a delay as well, so we're not presenting from the usual studio. So I hopefully the quality is good. So let's get going. So this week we're going to talk to you about programming fundamentals. So we're starting off. We're starting off with processing. So you'll notice from induction, we said that for the first 4 weeks of lectures, we're going to be using processing and then we'll move on to IntelliJ. So today we'll get started with processing. During the lecture today, I might ask you to jump onto processing and to try out some of the things that we're doing. So if you can have processing open, that's great. So if possible, use the latest version. So again, you go to processing.org and you just download it. Again, you can download it to a Mac or to your Windows machine, whatever it is. I'm using a Mac today, but I usually use a Windows machine. If you have any issues, and I know at induction 1 or 2 we had, again, just let us know, pop the message into Slack, and if we need be, we'll jump on later on after the class and we'll have a little one-to-one session with you. Okay. So when you go into it, you're going to configure your sketchbook folder and have a look at the font size. And again, I'll show you that now in a second. And there are some books that are available. So if you go to the processing.org website, you'll be able to see books that you can use or that you can look at. Again, you don't need to. For what we're going to be doing over the next 4 weeks, you don't need to have a book. Some people love having books and they love having a reference guide. There's a reference guide on processing website that is sufficient for everything that we're going to be doing. And again, you can ask us, but there, as said, there's books there available that you can have a look at. Okay. So what are we going to do today? So today we're going to have a look at processing, why we're using it. We're going to have a look at drawing, talk about the coordinates. So we're going to talk about pixels and how we relate to the screen, and a little few tips for yourselves on how you can figure out where something is supposed to be. Okay, we're going to look at functions. So we're going to look at the built-in functions that are in processing. So luckily for us, processing comes with a wealth of functions that we can use that we don't have to worry about. So we can give it the information it needs to draw a rectangle, to draw a line, to draw an ellipse. So that's where, it's a really fun environment to start learning in, because there's quite a lot of functions that are there that we can use. We're going to have a look at how we change the size of our screen and the background color. And then we're going to talk about some of the kingpins of, programming: sequence, selection, iteration. So we'll be talking about how coding goes from top to bottom and works in sequence. We're going to be talking about how selection, how we can make it go down different paths, and we can talk about iteration, how we can make it do something over and over again. We're going to have a look at colour and how colour is made up, and we'll talk about mixing of red, green and blue, which is our RGB colours. We'll have a look at errors and discuss the difference between syntax and logic errors, and how we fill our shapes, how we make them appear, whether they have an outline or not, and how thick that outline is. And then we'll talk about something very important of commenting. So why we comment our code and how we should comment our code. Okay, so and then our lab, we're going to have a look at, in your lab, what you're going to do this week, we'll quickly show you what the exercises are before the end. Hopefully we get there. Okay. So I just want to just back to something there. Okay, so we go have a look at our next set of notes and we get started. Yeah, sorry about this. I should have had them open for you. Okay. So where are we starting? So in induction, we had a look at processing, and I've seen, as I said, some of the great stuff that you've been doing over the past couple of weeks in processing. So as you can see, for those who've got started, it's easy to get started. It's easy to produce something. It's easy to see something, on a screen. So what we need to do is we need to take kind of a step back and really figure out why we're doing what we're doing and how we're making it look a certain way. Okay. So what is processing? So processing is a programming language, it's a development environment, and it's an online community. It can be used to develop static or interactive online material and data visualizations. So it's a programming language that was started for visual art by a visual artist, and you can see it's really visual when we go to use it. We're drawing things on the screen. We're making them appear different colors. We're making them appear in different places. We can add interactive elements to it. So, we can really make our code work for us and see how, as I said, our kingpins, how sequence works, how our selection works, how our repetition works. So it produces visual and interactive representations of programming code. So we can see straight away when we write a piece of code what it does. We don't have to wait like in some other languages and go through a lot of pain to actually see it print star to the console. What we can see straight off is, shapes. We can build houses. I saw cats, I saw dogs. So we can really make a nice visual environment. Okay. Different programming languages can be used with processing. So we're going to use Java with processing, but you could use JavaScript, you could use Python. Okay, so if you're at home and you want to learn other things, it's a good place to learn other languages as well. So you can still use the processing environment, but you can use it with different languages. So we're using Java because we're going to move to IntelliJ in at week 5, and we want to be able to bring what we've learned with us in a similar environment. So that's why we're sticking with Java now. There are going to be functions that we're not going to bring with us into Java, and they are the processing specific inbuilt functions. And we'll talk about those as we go through it. Okay. It can be used on different platforms. So Windows, OS X, Linux, and Android. So as you can see, I'm using it on a Mac, and some of you at home would be using it in the Windows environment. Okay, so in our induction, we talked about the coordinate system, and we said that in geometry, we use this type of a coordinate system. So what we say is the X and the Y, and we're used to from school learning about X and Y. But in maths in school, in maths in school, our X, Y, 0, 0 was in the center of the page. In processing, our point 0, 0. In processing, our point 0, 0 is going to be the top left-hand corner. So that makes a huge difference to us. So when I talk X and Y, I'm talking the width and the height. When I talk numbers, I'm talking pixels. So when I tell you, 1, 2, 3, 4, they're the number of pixels we're going to move across the screen. So 0.00 is the top left-hand corner, and it's no pixels right, no pixels down. When you're trying to figure out what a pixel is, it really depends on how big you're making your screen, and we'll talk about the size of our display, and that's when we're going to know how many pixels we're going to go left or how many pixels we're going to go right. And again, I always use ruled paper when I'm starting out because it really helps to figure out where we're going to place something on our display and to get an idea. But when we're looking at those numbers, what we're looking at is pixels. Okay, so when we open the processing and click on the run, a display window pops up. So when you press our run button here, this window here is going to pop up. If we've written no code at all in our processing, the display window that pops up is 100 wide by 100 height. So that's its default, 100 by 100. So our display window that's here, by default, it's going to be 100. So if I wanted to draw something in the middle, I would go over 50 and down 50. And that's where 50, 50 is. And I know that because I know my default window is 100 pixels by 100 pixels. Okay. So if I want to change where I put my display window, I can have this surface.setLocation. And what that's doing is that's using an inbuilt function, setLocation, to set the location of my display window. And the values that are here are where the position of the top left-hand corner of my display window. I haven't said what size I want my display window, so it's still going to be 100 by 100. But what I'm doing here is I'm saying where I want it to appear. So let me try that out for you just to show you. Okay. So I'm just going to take this one out here. So if I say set location and I have 100 by 100, my display window pops up and it's 100, that's my display window is 100 pixels wide by 100 pixels high, and its top left hand corner, its position is 100 pixels from the left hand of my screen and 100 pixels down from the top of my monitor. Okay, if I change that here to 400, you're going to see that this guy here is going to move over because that's my X value. And it moves over. And if I change this one, that's the distance from the top of the screen to the top left-hand corner. So if I change that, it'll move down. Okay. So you can see here that it's moving around. My screen here is quite big. So I think it's 2000 pixels by 1000. I can't remember the exact figures, and I know I should know them because, but anyway, so that's, roughly where I am at. So you can have a look when you're playing with it, have a look at your screen and have a look at where you're placing your display. Okay, and we'll get back to that in a second. I'll get you to do some other stuff so you can have a go at it. Okay, so the display window is where your code is run. It follows the rules of computing coordinate system in that the top left hand corner here is 0, 0. And point 10, 20 is 10 pixels to the right, so it's here, and 20 pixels below, so we go down. So when we have a point, so point is just a point, again, it's in pixels and we're saying where it is. So we're saying where it is in relation to the top left-hand corner. So how many pixels left, how many pixels right. So the pixel we can see is very important when it comes to our coordinate system, and working out where we're going to put our components onto our display window is extremely important. And that's why I always suggest when you're starting out, use the lined paper and figure out from the lined paper where it is that you want it to appear. So we have a tendency when we program to just get started. Just let's see, let's kick it off and see what happens, and I'll try it there and I'll put it here. And that's fine and it's great, it helps you work things out. But if you can sit back and before you even start, work out where you want it to be, so that when you actually input the coordinates, you know it's going to be in that place. And the reason for that is because when we move on to IntelliJ and Java or any programming language, it doesn't matter what programming language it is, the hardest part of programming is working out the steps for it to do what you want it to do. So you want you want to check how to do something. The code will come easy after a while, but it's the steps to get to do what you want to do is the hard part. And that's what you need to be able to take a step back and figure it out. Okay, and then write your code. So what are functions? So in processing, we call pieces of code that work together, a set of instructions, we call them a function. So processing comes with several pre-written functions that we can use. A function comprises a set of instructions that perform some task, and when you call the function, it performs the task. Okay, so what exactly is it? So a function knows its job. Built-in functions are functions that somebody else has written for us and we just call them. Over time, we're going to write our own functions and we'll write them and call them ourselves. But for now, we're going to use the functions that come in processing. So RECT, rect, square, line, oval, circle, and triangle, they're all functions that some nice person has written the code for. We will tell it, we'll give them the values of where we want the rectangle to appear, how big we want it, and they're called parameters, but it will take the information we give and it will produce the rectangle based on that. So they're what we call inbuilt functions. And again, we can go and have a look at the processing website and you'll be able to have a look at all of the inbuilt functions that are available to you on processing. And again, as I said, we're going to create our own. So if I want to draw a rectangle, the key word is rectangle. That's the function name. So that's the function I want to call is RECT. To that function, it's expecting in this format for me to give it 4 values. So it wants me in pixels to tell it where the X and Y, so where the top left-hand corner is going to be. And then it'll want me to tell it how wide I want it to be and how high I want it to be. Again, all in pixels. So let's have a look at that. So I'm going to, so that's the location. We'll take that, we'll leave it in. I'm going to say the size of my display is going to be 500 by 500. So you'll notice, and we'll get to it in a while, that I'm putting this semicolon at the end here. And that's just a rule of our Java programming language. It expects us to put a semicolon at the end of every statement. And it knows that that is what you want, the piece of code you want to be executed. Okay, so now I've said the size of my display is 500 by 500, and I want to draw this rectangle. So I'm going to draw a rectangle. I need to tell it where I want it to be on my display window. If I say I want it to be at 0, 0, it's going to be in the top left-hand corner. If I say I want it to be 100 pixels wide and 200 pixels high, and then semicolon. So you can see it's after drawing this rectangle. I haven't given it any colors. So by default, the background is grey and my rectangle is white. And you can see here it has a black outline, and the black outline is black. So these are all defaults. So you can see here I'm telling my code, draw the rectangle, draw it at 0, 0. So draw it in the top left-hand corner. And I want it to be 100 wide by 200 high. If I change that, so I want it to be halfway across. So I want it to be at, I don't know, 250. So it's going to be halfway across the X, and it's going to be still at the top. You can see that this here is my top left-hand corner. It's 250, so it's halfway across on the X, and it's on the top, so it hasn't come down anything on the Y. And if I change that to 50, you'll see that it's coming down by 50. So rect is an inbuilt function in processing that we call. It expects these four pieces of information. And the first two pieces of information, it relates to the top left-hand corner. So the X and the Y of the top left-hand corner. And then the next piece is the width and the height. Okay. And if we follow the rules that are set out by our programming language, then we can make it do what we want it to do. Okay. So again, we've just drawn the rectangle. So we tell it the X, Y, top left-hand corner, the width and the height. Okay. So if you want to just try that there for a second and get your rectangle going, and let me know if there's any issues. Okay. So hopefully that gave you enough time just to try out the rectangle. If it's not working, if you're having any issues, just let Mairead know. She gets lonely when she doesn't have anything to do. Okay. So again, as I said, note the semicolon at the end of every statement. The semicolon is our statement terminator, and it has to be included. You'll find we're going to talk about logic errors and syntax errors in a while. If you don't include it, you're going to get a syntax error. So processing in Java knows it's expecting this. And if it's not there, it'll tell you. Okay, it doesn't put it in. You have to still go back and go, oh, where is the semicolon missing? But it's expecting you to have to put this semicolon in. And that's telling processing that this is the statement that I want to be executed. Okay. If you want to draw a line, so when you want to draw a line, again, some nice person has written this code for us. It expects 4 parameters. It expects the X and the Y of where you want the line to start. and it expects the X and the Y of where you want the line to finish. And again, remember, this is in pixels. So our example on our screen is just showing you 6 pixels by 6 pixels. So if you have lined paper yourself, you can, put it into whatever ratio it is based on how big you want it to be, and then you can decide what is each line. So if you want them to be 10 or 20 pixels or 30 pixels, it's up to you. And how big the lining of the paper, that's completely up to you. So again, it's just a visualization, because some people can be really, really good at writing the code, but they can't visualize where it's going to be. So as we program, we learn a lot about ourselves, and we learn what we're good at and what we're not so good at. So again, I'm not great really at visualizing. I need to write it down. So that's why I would start with my pen and my paper. I draw out on my page where I wanted to go. I would have a look and see, roughly, it doesn't have to be exact. I'd have a look and see based on my lined paper where everything is going to be, and I would plug in those values. Some people just plug in the values when they draw their line, and then they keep playing with them until they get them right. Okay, and I'll show you what I mean by that. Okay, so this is our rectangle. So let's say I want to, so there's our rectangle. I want to draw a line from this point here to this point here. Okay, again, that can kind of be really difficult. So if I was on my piece of paper, I would know what this point here is, and then I'd be able to work out by adding the width, that'd give me the Y or the X for this point. Adding the height would give me the Y for this point, and I'd work it out. Or what I could do is I could just draw the line and keep trying to fit it in until it gets right. So what do I mean by that? So if I say I'm going to draw a line, it expects the starting point of the line. So I know that my rectangle starts here. So it's a good guess if I give it the same value. But now I need to figure out, how do I figure out what this value here is? Now I know that it's actually this value plus the width. So it's going to be 350. But let's say, for example, I put in 250 and I put in, I don't know, 300. So when I run it, actually, it's after going to the wrong place. So that's not where I want it to be, because look, it's gone in a straight line. So I know I want this point to be over here more. So that means I need to change my X. So I'm going to add to my X the 100. And I can see that it's actually gone over to the right place now, but it's gone down too much. So my Y value here is wrong. So I know it's 50 plus 200. So that's 250. And when I run it, hey presto, it's after doing that correctly. So I did that there by trial and error, trying to figure out where it was supposed to go, maybe based on mistakes. And that's fine. What you can do is, again, on your paper, you could work it out, and then you would have worked out that this was going to be your XY for the start, and this is going to be your XY for the finish. So your line has 4 parameters. The first 2 are the X and Y in pixels for the starting point, and then the second 2 are the XY for the end point. Okay. And again, you can draw your line and you can click to run. So what I'm going to do is I'm going to let you just put that code in, because it keeps building on it. So if I give you just 2 minutes there just to put that code in, and then press play, and hopefully it's working for you. Okay, so hopefully you've had a chance to get that done, and it looks like the two rectangles and the line. If it doesn't, just give Mairead a shout, and she can have a look at your code and see. So again, points to note: inbuilt functions are functions that come with processing, and they're being created so that we can call upon them. And when we call them, we pass them the information that they need to do their job. So with the rectangle, it expects 4 parameters: the x, y, top left hand corner, and then the width and the height. And the line expects 4 parameters also. It expects the xy of the starting and the xy of the finish. Okay, so an ellipse. So an ellipse can be a circle, and there is also a function for circle, but an ellipse can be a squashed circle as well. So because of that, it has a width and a height. So again, it has the xy. In difference from the xy for the rectangle is it was the top left hand corner. The xy for our ellipse is going to be the center point. So the information it requires is the center point xy, and then the width and the height. And again, it can be bigger or smaller. If you create an ellipse that's bigger than your screen, it'll still draw it, but it'll be off the screen. So just to keep, again, know what your pixels are, know how big your screen is, your display is, and know what it is you're trying to create. Okay. So again, you can add in the ellipse. So I'll give you a second to do that. So again, on line 4 there, we're adding in the ellipse. We're telling processing, I want you to draw this ellipse. Here's the information you need. You need the xy, which is the first 2 parameters. So I want it to be 85 left from the, 85 across from the start. And I want it to be 50 down. And that's where I want the center of my ellipse. And then the width of it is going to be 20 and the height is going to be 60. Okay. So again, a circle is like an ellipse, except it doesn't have a width or a height. It has what we call the extent, which is the diameter. So it'll have the center point as the xy, and then the diameter, how wide and high do you want it to be, because a circle is equidistant. Okay, and again, there's our circle. Our circle needs 3 parameters. The xy is our first, so the xy is the center of the circle, and then the diameter is going to be 15. Okay, so if you think of that, the diameter, that means that it's 7.5 pixels each side from the center point. Okay, so it's the diameter. So again, when you're starting off, these all seem fairly okay, but it's just knowing where they're going to be on the screen and making sure that when you're putting these functions and using these functions, that you know that you're using them in the place of where you want them to be. And again, as I said, you either write it out, you design it with a piece of paper, you use paint. Paint has rectangles, has a lined paper. You can put your mouse anywhere on paint and it'll tell you what the XY is. So you can do that as well. Or you can, you can use any other drawing tools to help you out. But I want you to know that when you put it on, you're not just guessing where these are. There's a reason for each of these parameters, and there's a reason why you're using them in the way that you're using them. Okay. So we said that the Windows is 100 by 100, which is quite small. So by default, if we don't change the size, it's 100 by 100. Whereas we can change display window. So if we say size and then give it two values. So again, size is an inbuilt function. It expects 2 values, and it expects a value for the width and a value for the height. So we'll tell it how wide we want it to be, and we'll tell it how high we want our display window. And when we use the size function, it should be the first line of code in your sketch, okay? Because we're going to talk in a while about sequence and how we need to do everything in sequence. So your size should be always the first line, because that's you're setting out your stall. You're saying how big you want your display window to be, okay? So we can see here that the code hasn't changed, but we've made it bigger. So now it's squashed up into the top left-hand corner. Okay. So again, we have lots of inbuilt functions and we just use them in order. So we'll get to that in a second. So it looks less cramped, but maybe we want to change the default color, and we could set the background to color to be something else. So as you can see here, when we created the size, we haven't any colors there. So we're just telling our code, just use the default. Unless it knows differently, it's just going to use the default. So what is color? Okay, so if I give it one value, okay, for grayscale, and we're going to talk about RGB in a second, but when it's just one value that's passed, it's going to give us a value between 0, which is black, and white, which is 255. So I know Pete in our induction, he talked about switching the light on and off. Okay, so when it's at 0, that button is off, so it's black, and then when we switch it on and give it full force of 255, that's when it becomes white. So that's when we're giving it its color. And there is a reason why we have 255, and it's all down to bits and bytes, and I won't bore you with those unless you want me to, but that's why we're using 255. So when we're talking about changing the colors and making something a color, if we just pass it one value between 0 and 255, it's going to be some value of gray. The closer to 0 it is, the darker. The closer to 255 it is the lighter it's going to be. And you can see there that there is a reference there for tutorials color, and you can have a look at that yourselves. Okay, so if in the background I use the inbuilt function background and I give it one value, it's going to be a gray color. Okay, so you can see here, if I change the background here to 250, because that's closer to 255, it's going to be some sort of a white background. So if we have a look at that, so if I say background, and if I have it at 0, it has it as black. If I change it to 10 to 100, again, it's closer to 0, so it's going to be a dark color. Okay, and then if I change it to 200, it's closer to white, so it's going to be lighter. Okay, so that's our color. When we want it to be a gray color, we pass it one parameter, and we're going to learn about what we call function overloading in a while. But what that means is that we can have the one function name, but when we pass it different parameters, it does something differently. Okay, so in this case here, if we pass in one parameter, it produces a gray color for the background. And if we pass it 3 parameters, it's going to produce a color for the background, and we'll get to that in a second. Okay. So programming is problem solving, and that's something I think we kind of forget when we start coding, because we're trying so hard to get to, I want to see the code on the screen, I want to do something, I want to do something, that we forget actually just to take the step back and say, what is it we're trying to solve here? What is the problem we're trying to solve? What are the steps that I need to take to solve this problem? And when you take your step back and you figure out the steps that you need to take, then the coding comes easy. But when you try a little bit like, keep ramming the square block into the round hole until it goes through, it will eventually probably go through if you hammer it hard enough. But that's not what we want. We want you to figure out, first of all, actually, I'm going to put the square peg into the square hole. I'm going to put the round peg into the round hole, and then everything will be okay. So we want to solve the problem first. And we need to figure out what are the steps that are involved to solve the problem. So when we want to solve a problem, everything that we need to do has a flow of control. Okay, so if I ask you to make a cup of tea, you have to think in your head, what are the steps involved to make the cup of tea? Okay, and even to make the cup of tea, there's a sequence. Okay, so you have to do something in order. There's a selection. Some things will be done conditionally. So you'll check and see, is there water in the kettle? If there is, switch it on. If there isn't, walk to the sink and put water in the kettle. There's iteration, things that have to be done repetitively. So walking, like one step, how many steps to get there? How many times do I have to move? So these are all things that when we're writing programs, we have to think about. We have to think about what's the sequence, what's the route through my code, or what are the routes through my code, and what needs to be done over and over again. So what is our iteration? In our pre-induction club, we concentrated on sequence, and today we're going to look as well at sequence, but we'll cover selection iteration as we go along. So an example, and I think we looked at this in the induction week as well. We talked about the sequence of the instructions in processing, and when our code runs, it runs from top to bottom. So if we look at this code here, the first thing it's doing is it's drawing size. It's making it 400 by 300. The second thing it's doing is it's getting the background. It's taking the one parameter, which we know is going to be a grey color, which is 250, which is almost white because it's nearer to 255. And then it's drawing the first rectangle, then the second rectangle, then the line, then the ellipse, and then the circle. Okay, so that's why it looks the way it looks. So what will happen if I move the background somewhere else? Okay, so let's have a look at that. I can't copy and paste that, so I'm just going to look at there. So I have a rectangle and I have a line. I'm just going to draw in ellipse at 85, 50, 20, 60, and a circle. It would help if I spelled properly. At 50, 80, and 15. So when I draw that, it's drawing the background, it's drawing this rectangle, it's drawing that line, and it's drawing the ellipse and the circle, and it looks good. If I change this piece of code here, and I put it here, what happens? My rectangle and my line disappear, but we know it drew them because it starts at the top and it works its way down. So it did draw this rectangle, it did draw this line, but what happened is it then drew the background, which drew over those, and then it put the ellipse and the circle onto my display. So order matters. So when you want to make sure that you're doing that, you've got the sequence right, you need to make sure that the order of instructions are in the right order. Otherwise, even though it has drawn those two, can't see them anymore because they're behind the background. Okay, so be very careful when you're thinking about the sequence, because it overwrote what was there. And that's what happens in coding. Okay, so that's why we have to be very careful about how we go about coding, how about we come up with our set of instructions and in what order we're going to do them in. Okay. Any questions? Throw them into Slack. I'm going to give you about 10 minutes of a break. Actually, I'll give you 8 minutes if that's okay. We'll come back at 10 past. I'll put up a timer and we'll come back and we'll start the next set of slides. Okay. And we're back. So I hope you had a little break. Over the 12 weeks, just so you know, as regards breaks, um, they'll be taken at different times. Sometimes we'll give you work to do over your break, and otherwise, you just had to go have your cup of coffee or your lunch or whatever it is you're having. Just to break it up, because it's a long time to have to listen to me. So we try and give you breaks every now and again. And as we go on, there'll be a lot of time when you'll be doing some of the examples. So, and then you can fast forward when you're listening back. So if you're listening back, you can just fast forward to that 8 minutes break. You don't have to look at it. So one of the questions I noticed, Mairead has been doing a great job answering all your questions. Don't be afraid to ask her questions, because she loves answering them. She gets bored because she's in a little pod at the moment and there's no one to talk to. So she gets fairly bored if you don't give her questions. But I noticed that one of the questions was around where do we find the processing functions. So let's have a look and see. So if we go into processing.org, you can see that there's different things you can look at. So it says welcome to processing, that's where you download. So you can go into documentation, you can go into learn. In learn, there's tutorials and examples and books. In documentation, you can go in and you can look up the reference, or you can go down here to reference. And then it'll give you a lot of the functions that we're going to be using in different the different libraries that they're in. So you can see here that today we're looking at shape. So if I go to shape, I can have a look at the 2D primitive shapes that we're looking at. Okay, so we're looking at circle, we're looking at ellipse, we're looking at line, point, rect, square, triangle. So let's have a look at triangle first. So you can see here, when you go into triangle, it gives you a piece of code. So it gives you the piece of code that's going to draw this rectangle. So I'm not going to tell you what those values are, because it tells you down here. So it tells you that you need 6 parameters for a triangle. The xy of each of the points. So the xy of that point, the xy of that point, the xy of that point. Does it matter which is the first point? No. So you can give, that can be xy1, y11, this can be x2, this can be x3, or that can be x1. It doesn't matter as long as you give it in order, which no matter what way you do it in a triangle, it's in order. So you're just telling it that these are the 3 points in our triangle and these are the coordinates. Okay, so that's going to be your syntax. So if you want, you can just copy that in, and then you can go back to processing, and we'll do another one. We'll go file and new, and paste it in and run it. Oops, and I threw it over here first, and you can see that it drew the rectangle as is. So in processing.org, there's loads of reference, there's loads of help. If you go back to documentation, go back to reference, if you want, if I say something and you kind of go, oh, I don't know what she's talking about, you can actually just type it in here. And of course, that one doesn't come up. You can just type it in here and it'll come up for you. Okay, and it'll come up there. So this is your first port of call. I think W3 Schools also has, again, I probably should have looked it up first. Just processing. No, it doesn't. So yeah, so just the tutorials that are there, that'll give you help as well. Okay, so stick with the processing.org and you should be able to get some good help there, I think. Okay, so let's get going back to our notes. We get rid of this. You would have thinking in 8 minutes I would have had myself prepared, but obviously I decided against the whole preparing thing. make sure that's it. So I'm kind of presuming you're all helped me. Okay. Just I saw Mairead put in a question about do you have delays? If you have, I apologise. It's we're not going live from our usual lab scenario or our usual pods. So hopefully, if there is an issue, that it'll be fixed by Wednesday. But if not, and we're good, that's good too. Okay, I'll get rid of me. You don't need to see me. So let's have a look to our static drawings. Okay. So we had a look at our size, and we have our example. So we said that this is a static drawing, and what that means is that it doesn't move. Okay, so we run it, we press play, it produces this once, and that's it. Okay. Now, to add insult to injury, my second screen is after dying, so I hopefully we're still good to go. And just give me a second, sorry, till I see can I get it to come back. Usually if I play with the wires, it comes back at some stage. And there we go. Okay. Yeah, we're having a great day, really. Sorry. So static drawings are drawings that don't change over time. So once they're drawn, they don't change. So they don't respond to events like a mouse moving over the sketch or a key being pressed. And that's where you're going to have your fun. You're going to have lots of fun over the next while, being able to bring in event handling. So what that means is that you press, the space bar and something happens. So for anybody who has grown up in the Flappy Bird era, where you kept pressing your space bar to make the bird fly, this is great because you're going to be able to do that in processing. Anybody who plays any of those games where you have to like make a ball go through something, you can create those. You can create for people who are a little bit older like me, who had ping pong, the pong game, where when I was a child, it was like the most amazing thing that you could possibly have. It was like a little thing where you had a knob that you went up back and forth with, and it got the paddle to go up and down, and it made a very specific sound. Or Space Invaders, all of those great games, you can create them in processing. But at the start, for this week, for this session, we're just looking at static drawings. So again, we've had a look at the colour, and we've said that if we give one colour, it's going to be grey. So with colour, we can also include the red, the green and the blue. Now, some of you amongst us are quite creative, so you've got a good knowledge of colour. I'm very bland, and anyone who ever sees me will kind of know I possibly wear black most of the time, matches my personality. But anyone who's good with colour can really make their assignments look really interesting by the colours that they use. So all the colours that we create are going to be a mixture of red, green and blue. And like what I said before, when I said, it's going to be a value between 0 and 255. 0 means there's going to be none of that colour in it, and 255 means it's going to be all of that colour in it. So when I have the switch on for red, it's going to be red. And, if I have the switch on for green as well at 255, then it's going to be some sort of a purpley colour. Well, actually, I don't know what colour. Maybe it's brown. I don't know. We'll have a look and see. When you mix red and green. So we're going to learn that we can mix the colours and we can make whatever colour we want. Okay. So digital colours are made by mixing the 3 primary colours, red, green and blue. Okay, so in processing, we have this colour selector. So if you go to tools and go to colour selector, so let's have a look at that. So in here, I'm just going to stop that for a second and stop that one for a sec. So in here, I'm going to go to tools. Again, yours might look slightly different than mine because I'm using a Mac. You'll probably have yours across here on the windows. So I'm just going to the same thing, it's just up here on tools, and we can go to color selector, and you can see here then you can create your color. So you can drag it across, you can make it red, so you can drag it here, and this is the color you're creating, and this is the mixture of red, green and blue. Now you can also copy the hexadecimal value, and I'll show you that in a second, but this is the mixture of red, green and blue, and you're just going to use those values to create whatever color it is that you want to create. Okay, so we'll have a look at this in a second. So you can see here that this is your color selector, and you can create it. You can, if you want, in like the likes of Paint, Microsoft Paint, you can have an image and you can pick the color you want from the image and find out what the mixture of red, green and blue is as well. And there's loads of help online to picking colors. Okay, so there's the Adobe color wheel, so you can go in and you can create your colors. Again, it's doing exactly the same thing as this. It's creating color made up of red, green and blue. Okay. So background, let's go back to our great inbuilt functions. So as I said, for us, luckily for us, processing comes in all these built-in functions that help us, and we're just calling it, we're calling those functions and we're giving it the information it needs to do the job that we want it to do. So background is one of our overloaded functions, which means that we can give it different types of values and it does something different with them. So if we only pass it one parameter, then it's going to have a grey color. If we pass it 3 parameters, then it's going to have a mixture of red, green and blue. And if we pass it something and have the hex, have the ampersand in front, not the ampersand, the hash symbol in front of it, it's going to produce the color based on the hexadecimal value. Okay, so for the hexadecimal value, each pair of numbers is the hex value for the decimal 0 to 255. Okay, and again, we saw when we went into the color wheels and stuff that it gave us the value in red, green and blue, and it gave us the hex value as well. Okay, so let's have a look at changing this. So if I go back to my code, I'm going to use this one here. So it's 175.48.107. So it's 175 48 and 107. So I can close that off. And when I run this, it produces that nice magenta color that I had earlier on. Again, don't forget about your sequence. If I put it in the wrong place, it colors over my rectangles. Okay. So you can see here that this background here of 190, 240, 245 produces this kind of, I don't know what color you'd call it, blue. Color is one of those things that I see blue, you see green. And maybe online it looks slightly different, but I'm telling you, it's kind of a bluey color. And you can see that it's made up of a lot of red, more green, RG, more green, but it's mostly blue. So that's it. You see, it is a bluey color. But it's mostly blue. So almost the same, green and blue, but mostly blue. So that's why it's this color. And again, you use whatever it is, whatever tool you want to find out the color that you want to use. But when you have the background, if you pass it 1 value, it's going to be grey. If you pass it 3 values, it's going to be a color. And it's a mixture of red, green and blue. Okay. And again, you can put the hexadecimal number. Make sure that you have the hash symbol, otherwise you'll get an error. And 2 characters represent the decimal number from the RGB code. So if I go back, BE is, I should know it, 190. So BE if I was to convert that to decimal, that would be 190. Okay, and when you're doing your networks, you'll be able to change this. So yeah, we won't even embarrass myself by making me do it in my head. Okay, so earlier on I talked about syntax error, and I said that if you hadn't got the semicolon at the end, it was a syntax error. So we'll have seen the term syntax mentioned before. So syntax are the rules you must follow when writing well-formed statements in a programming language. When you don't follow the rules, processing will not run your code and you'll get an error. Some syntax errors, examples are on the upcoming slides. So when we're talking about syntax errors, they're easy to spot because processing will tell you about them. So a syntax error is when you don't follow the rules and it won't run. Okay, so you can see here that background is spelled incorrectly. So processing is case sensitive, and that's good to remember. So you can't put in a mixture of uppercase and lowercase and expect it to do the same thing over and over again. You must follow the exact naming convention. So it's case sensitive. So if you put in the uppercase in the wrong place, or you spell it incorrectly, or you put in wrong parameters, whatever it is, you'll get this. See this, the function background int does not exist. So it's telling you, I don't know what this is. So it doesn't tell you what's wrong exactly. It just tells you there's a problem here, you need to fix it. Okay. So in this case here, it's telling you background is spelled right, but I've passed in too many parameters to it. So it doesn't know what it is you want me to do. So it doesn't know this built-in function. So if it doesn't know it, it gives you an error. So the background function has too many. So RGB is defined as 3 and the grayscale is 1. Okay, so there's too many for our background, so it doesn't know what to do with it. It doesn't just take the first 3 and go, I'd say you meant the first 3, didn't you? It doesn't do that. It says, hey, I have no idea what you're doing here. Could you fix it? Okay, so it tells you it's wrong, but doesn't tell you why. Okay, if we have a missing semicolon, it tells you there's a missing semicolon, okay, on that line. Funnily enough, sometimes it points to a different line, or it might tell you that the problem is on line 4. So sometimes you need to be careful where it's telling you the error is. It mightn't be on that actual line, it might be on the line previous. Okay, so again we said a semicolon is needed for each line. It's the statement terminator. Now, syntax errors are annoying, and sometimes they're hard to figure out where it is, but you're told there's an error, you know you have to fix it, it's not going to run until you fix it, so you go ahead, you fix it. They're not an issue because you're being told. Logic errors, on the other hand, are a nightmare. In computer programming, a logic error is a bug in a program that causes it to operate incorrectly, but not to terminate abnormally or crash. A logic error produces unintended or undesired output or other behavior, although it may not immediately be recognized as such. Okay, so what does that mean? It means you've written your code is running fine, everything looks good, but it doesn't do exactly what you expect. And trying to find out why it doesn't do exactly what you expect is an absolute, it's a minefield. And you might not know that it doesn't do exactly what you expect until many months after, many years after it goes live. So there was a case last year when in the bank where all the students in Ireland were taking out money out of their Revolut, or transferring money into their Revolut. They were transferring money from the Revolut into their account, and then they were taking it out of their accounts. And that was because there was a logic error somewhere that they hadn't thought about when they were writing the code, and all of a sudden there was a loophole that people could take money out that they didn't have. Now, all those students had to pay it back because the bank always wins in the end, but a logic error produces unintended or undesired output. So it's something that you have to be fairly careful about. And when we start coding, you're going to hear a lot about curly braces. Curly brace, open curly brace, close curly brace, close curly brace. The amount of errors that are caused by curly braces being in the wrong place, closing, terminating a piece of code where it should be the next line, yeah, incredible. But yeah, a logic error is a bug. So say we wanted a pink background for our display. So the RGB is 255, 51, 204. And we incorrectly enter the G color as 551. So it doesn't give us an error. It thinks it knows what it has to do, but it doesn't produce the correct color for us. So that's a logic error. We wanted it to be pink. It's yellow. It looks grand, but it's not what we wanted. Again, we'd fix that one fairly easily because we'd see it straight off. But if it was something else, sometimes they're harder to find. And that's why we have testing. And we will be doing some testing ourselves. And if you work in a company, you'll have probably an organization, some people in it who'll test your code, and they'll test it against certain scenarios to make sure it's right. But logic errors are bugs. Okay. Any questions? So if you have any questions, pop them in. I'll have a quick look and see. Okay, I think we're good. I'm going to go on to the last deck of slides, and I'll keep going so that that's not that one. So I think this is our last deck for today, and then we just have to have a look at our labs. So one thing you'll notice about our slides, as we go through our slides, sometimes at the start of each set of slides, there's a little summary of what we've done already. And that's so that you can, if you yourself want to go back in and look at different sets of slides, they're not just standalone, they are standalone, they also be able to give you a little bit of introduction of what had gone previous. So when we're doing them in the live session, sometimes we will just go quite fast over the bits that we've just done in the previous slide deck, and that's okay. But it's there for you for when you're going back and having a look. So it really, you realize where the code that we're doing has come from as well. Okay. So let's look at this. So for this, we're going to look at filling shapes with color, formatting the outline of the shapes, and adding comments to our code. So we have said that when we want to create a color in our background, we use the RGB. So when we want to create a background color, we use the built-in function background, because that's what's been written for us to use. It's been written by processing, and it changes the background color. Likewise, fill. Fill expects different parameters. It expects one parameter, it's going to fill something grey. It expects 3 parameters, it's going to fill it a colour that's a mixture of red, green and blue. And we use fill with shapes. So we use background for the background. We use fill when we want to colour a shape. Okay, and those people who had nice cats and dogs, they would have used fill, and different versions of fill as they wanted to colour different shapes. And again, this is where sequence is going to be fairly important, because we want to create the fill color before we draw the shape. Okay, again, the colors are made up of a mixture of red, green and blue, and we've already had a look at that. Okay, so again, using this, everything was by default white. So we said before that when we draw on our shapes, by default, the shapes are white, are filled white, and the stroke around them is black. Okay. So what happens when we use the fill? So if we use the fill 100, 150, 70, that's producing this greeny colour. And you can see it's like as if it's putting the paint into the bucket, and then as the shapes are drawn, it's pouring the paint in on them. Okay, so it's filling the shape with that colour. So you set it up first, and then you draw the shapes, again in the order which you want them to be coloured in. Okay. If we want some of them a different colour, well then we add in the fill for that colour before those shapes are created. So again, the rectangles are filled with the dark green and the ellipses are filled with the light green. The order of statements matter, so the sequence matters. So you say in order what you want to be drawn first, and then the fill for those, and then what's coming after, and the fill for those. And the fill comes before we draw the shape. Okay. So again, when we only have one fill, they're all green. And when we have two fills, it has the two rectangles are filled green. So this rectangle and this rectangle. The line isn't filled because it's just a line. It's a stroke. We'll get to that in a second. And then we have a fill, and then the ellipse and the circle. So this ellipse and this circle is drawn based on this fill here. So if we want to change the stroke, the outline, so you can see here we have an outline here for our stroke, and we have an outline on our oval and an outline on our circle. If we wanted to make it look like this, so we wanted this outline to be thicker and this guy here, this ellipse, to have no outline at all. So we're going to look at more functions. And again, going back to the question, where do we find all this out? On processing.org, if you type in stroke, it'll give you more information about the stroke weight and the stroke, how to change the colour of it as well. So they're all in our processing. So if we say no stroke and we don't pass it any parameters, because it knows, whoever wrote this code for us said that if you call no stroke, then you won't get any outline on your shape. So we don't have to pass it any information. It has all the information it needs. By calling no stroke, that's all the information it needs. So a stroke is the outline of the shape. The no stroke function disables the outline on shapes that are drawn after the function is called. All shapes drawn after no stroke will have no outline. So remember, sequence is important. If you only want some of them to have no stroke, well then you've got to introduce the stroke again. Okay. So we can see here, we have our fill for the green, and it fills the green. We have our fill for the yellow, or the kind of yellowy green, and then we have no stroke. So you can see here it takes off the stroke off the ellipse and it takes it off the circle. But that's not what we want. What we wanted is to have it gone from the ellipse but on the circle. Okay. So the stroke function enables the outline on all. So when you call stroke, you need to specify a color. So we're going to create a color. Remember we said if we don't give it a color at the start, it's black. But if we take away the stroke, well, then we have to tell it. Okay. So if we say stroke and pass it 0, now our circle has a stroke. Okay. So I'm going to get you to try that yourselves. So I'll just give you 2 or 3 minutes to try that yourself. And just playing with the stroke and the no stroke. Sorry, that was just me playing while you were supposed to be doing this. So you can notice that on line 15, where we say stroke 0, 0, 0, when the value for red, green, and blue are the same, so 0, 0, 0, 100, 100, 100, 255, 255, 255, that means that it'll produce a grey colour. So you don't need to say, when the 3 values are the same, you don't need to say 0, 0, 0. You can just say 0 because that's what's going to be produced, but it doesn't make a difference. So when the 3 values are the same, it's always going to produce a grey colour. Okay. So for this one here, you can see, again, the thing you've got to take out of this is sequence is important. And we're filling it, we're saying we don't want a stroke, so it's important that before the shape is drawn you have set it up. So you can't say no stroke after the shape is drawn because it's too late. You can't say fill after the shape is drawn, it's too late. So you set up the colour you want it to be, you set up whether you want it to have a stroke or no stroke or what the weight of the stroke is going to be, and then you draw the shape. Okay. So stroke weight, again, the stroke weight is in pixels. So it allows you to choose the thickness of a line, and the chosen thickness will apply to all lines and shapes that are drawn after the function is called. So again, stroke weight, built-in function in processing, comes with processing. It expects one parameter. That one parameter is going to be the measurement of the thickness in pixels. And if we don't have a stroke weight defined, it's always 1. Okay, so you can see here our stroke weight is 3. So that's making it nice and thick here. And then we have no stroke. So this one here has no stroke. We go back here to having a stroke, but we don't change the weight. So it's still 3. Okay, so that's important to remember. Once you set the weight, until you change it by calling stroke weight to something else, it stays the same. Sequence and order, so important, and to remember that it keeps it until you change it. So adding comments. So the most important thing you can do when you're learning is comment your code. When you're in a job or when you're in an assignment, we will ask you to comment because we want you to tell us what's happening in the functions, what's happening in the pieces of code. We want you to show your understanding of what you're doing. When you're in a work placement, it's really important that you comment your code because others need to be able to maintain your code. So they need to be able to know what it is you're doing. Okay? But when we're learning, we comment our code and it's like little notes we leave ourselves so that we know what's happening. So when you write all this code that's there on the left hand side, when you're doing it and I'm talking, you're reading it from somewhere, you're typing it in, it makes complete sense. Fail 100, 150, 70, absolutely, yeah, totally know what that means. Rect 100, 100, 200, 100, yeah, absolutely know what that means. Tomorrow, when you look at it, haven't a bloody notion. What's the 100? What's the numbers I can use again? What did they mean? God, there's a lot of numbers there that I haven't a clue. So what you do is you comment your code. So at the start, your comments are going to be, long-winded explanation just for yourself. So that tomorrow when you look at your code, you go, oh yeah, that's what she said. She said the first 2 are X's and Y's, and then the other 2 are the width and the height. Oh yeah, I know what she means now. Oh yeah, you have to be between 0 and 255. I know that now. So there are things that, you comment your code, things that make complete sense to you when you're writing them don't make any sense when you come back an hour, a day, a week later. So at the start, when we comment our code, it's usually for ourselves. Okay, so when we comment, we have //, and that's called a line comment. So that just comments out anything that comes after it in that line. And when we have /*, it comments anything that comes after it until it gets to */. And that's called a multi-line comment. So this guy here, //, that's just a line. And this one here is a multi-line. And comments are code that's ignored by our compiler. So I'll show you what I mean. So if I go back here to this, if I put in // here, and I say this sets the display window size in pixels. Okay, so that's an inline. So anything that comes after on that line is a comment, and you can see it's grayed out, so the processor is going to ignore it. The next line is back to normal, so it's only for that line there. If I wanted to, I could say /, where's star here, and then I could have an edge. So you can see everything behind it now is grayed, and it'll be grayed until I close my comment, and then I can write in here. Okay, so you can see here that when I have /* and close it with */, I can have my multi-line comment. So that'll help me if you have a lot to say about what you're doing. And again, I really suggest that you comment your code as much as you can when you're learning. And they're just little messages to yourself. As you get better, you'll still comment your code, because we always have to comment our code, but there'll be more explanation of what's happening, of what a function is doing, or a particularly, complex line of code if you have quite a lot of calculations. So you will be still commenting it. If you're in a work situation, you'll be given your coding standards, and you'll be told in what way you comment. So it could be you add your initials, you add the date of the comment, and you add a brief explanation of what's happening. So these are all different ways of comments, but the thing at the moment, you're going to comment your code because it'll help you remember what you're doing. Okay, so you can see here's the explanations. This is our inline comment, and this is our multi-line comment. And again, I really can't say it enough. I want you to comment your code. It'll just help you to understand it when you come back the following day. It doesn't affect your code at all. Okay, so it's, it doesn't affect how it runs. It just affects your understanding of it. Okay. So, summary of what we've done. So we looked at background, we looked at fill, we didn't look at no fill. So again, I would suggest you have a look. No fill is when it takes away the color you've added and it goes back to being the default for the next shape. We looked at stroke and no stroke. We looked at stroke weight. So you can have a look at yourself, stroke cap and stroke join. So what the cap is, you can pass it. Again, you can look these up on the processing.org in the reference. So the cap is whether it's going to be a rounded end of the line like this, the straights, and there's bevels, and there's different things. And again, for the join, how they join together, whether it's a mitre, M-I-T-R-E. I'm not sure whether that's a bevel or a straight, and you can have a look at that. We looked at comments, how we do inline or multi-line comments. Okay, and questions. So if you want to pop any questions in while I quickly open up tutors, and we'll have a look at your lab, and we'll just quickly talk about the lab that you're going to be doing. And then I promise you can go, and I'll stop talking and I'll go get a cup of coffee. Oh, I must have closed it, sorry. Okay. So again, this is today's. We added in first contact today. So when you go in here, you can see this will be, you're probably watching this live. We've gone through these 3 lectures. So you can see that these are all lectures because they have the little man talking. And then you've got a lab. On Wednesday, underneath this, there'll be a 1B. And I think it's called animating your shapes or something. And that'll appear underneath here. So on Wednesday, when you go live, you'll just scroll past this and it'll be underneath here. Okay. So this week I want you to do this lab. It goes through the lab advice, opening all this, and then what we've done today in class, a little bit about the red, green and blue and how we've done it. And you can see here, it gives explanations again based on what's in the notes. The changing the look. So again, that's the fill, the no stroke, all of that good stuff that we looked at. I don't know why he's jumped. There we go. And then you have exercises. And this is what we'll ask you to do. So we'll ask you to do these exercises as well. And you're going to draw the Microsoft logo like this and the Beats box. And then the solutions are here. So when do you look at the solutions? You look at the solutions if you can't do one of these, or you just want to check what you've done based on what is there. Don't look at the solutions until you've made a fairly good attempt yourself, and you'll see the exercises we want you to do, and then the challenges are a little bit more difficult. So there, once you've got the exercises done, it's up to yourself whether you do the challenges, but we would like you to do them, because the more you practice, coding is all about practice, 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 practice. So the more you practice, the better it is, the better it is for you. So practice your code, make sure you understand it, comment it when you understand something, because what you want to do is you want to figure it out. Once you've figured out, don't think you're going to know tomorrow what you figured out today. So comment something when you figure it out. As you get better and you practice more, you won't need to write as many comments. Make mistakes, fix them, ask questions, all that good stuff. The more mistakes you make, the more you learn. If you get everything right first time, you're not going to learn anything. So that's why I would say take the code that we've done in class, play with it, change where the shapes are, change shapes, add triangles in, put them in different order, put them different colours, see what happens, do your exercises. As regards the labs, I'm not sure whether we have a lab tonight, but we'll definitely have one on Wednesday from 7 to 8. So we'll go through this on Wednesday. If you want, you just, if you don't need help, you're fine. If you want, just pop in and you can ask any questions, and we can jump onto Zoom, and we can have one-to-ones, or you can just ask them in Slack and we'll answer your questions as soon as we can. Right, that's it. Finished for the day. Thanks a million to everybody. I know I went right to the end. If anybody wants to jump on to Zoom at the end, just pop us a message in Slack, and we'll have a chat if you want to have a look at anything. If not, we'll see you on Wednesday. All right. Thanks a million. Talk soon.